Venkatesh, go to that last room. That Jiva, so many fellows are there. Come once, call them. What they are doing? Guru, turn off one.
It is very dark.
Okay. One is not enough. Huh?
No, sir. Okay, turn off the TV.
Turn off that and turn on this. Okay, Noma, no issue. No? Okay, so today, actually, I will send them quickly. Good evening, everyone. Our next topic is parallel LCR circuit. Parallel LCR circuit with an AC source. With an which source? AC source. For example, as of now, we have seen only series combination, no? So let us see parallel combination. I'm taking one inductor of coefficient of self-inductance L Henry. Just now you are coming, Vishnu. Okay, ma. And one more capacitor of capacitance, how much? C microfarad or C Faraday connected. And another resistor connected in the parallel. This is actually highly impossible circuit. Can you say why? In reality, every inductor is having less or more some internal resistance, na? So compulsory it should have some internal resistance here. Capacitance also made of metal. Metal also having some internal resistance. What happened? I think this side or that side in staff room. So it is a imaginary only, na? Why? Pure inductor, which planet you will go? So it is a imaginary case. Imaginary or hypothetical. Or which theoretical? Hypothetical. I mean, practically not possible. I hope you understood the logic. But anyway, here you will talk. I will put one cell of AC source. Let's say applied EMF, how much? E naught into sine of omega t. E naught is nothing but peak value of voltage and omega equal to angular frequency. Now all the three components are in the parallel combination, na? Yes or no? So I can write one statement. Voltage drop across inductor equal to voltage drop across capacitor equal to voltage drop across resistance equal to how much? Voltage drop across the source. As they are all are in the which combo? Parallel combination. Now let us observe after some t seconds. At the time of t seconds, tell me what is the current in the circuit? I is equal to current coming out of the cell, no? And after coming here, split into IR, it split into IC, and it split into IL. And now here phasor diagram is important. Phasor means what? Vector diagram. Vector diagram is very, very important. So tell me, sine omega t means, shall I write omega t plus 0? Yes or no? Omega t plus 0 meaning what?
0.
Applied voltage phasor along positive x-axis only, na? 0 meaning angle between this applied voltage and the x-axis 0 only. Yes or no? So I can write applied EMF E naught along x-axis. And you know one more thing also, applied EMF vector or phasor, current in resistance having the same phase only, na? Have you remembered that? I gave one important note. Current in resistance, if you have doubt, kindly check it. Current traveling in the resistance and applied voltage are in same phase. Very, very important note. This is the yes, important note, are in same phase. Every circuit is quite common. Whether it is series or parallel or anything, they are in same phase. What is the meaning of the same phase? If this become maximum, current also maximum. This becomes 0, this is also 0. This become negative means this is also negative. That is the concept of traveling by same phase. Okay. And now, what is the current in inductor? Lagging or leading? Very good. With respect to net EMF, lagging only, na? So I have to write it downside or upside?
Down y-axis.
Very good. I have to write it downside. So this is the current flowing. I mean peak current. What the length of the arrow is nothing but peak value of current flowing in the inductor. Understood or not understood? Then what is the I will tell you. I'm coming to that point only. You are about to ask that. And what about the current traveling in the inductor? I told you it is lagger. And what about the current traveling in capacitor? Leader. So leading to this applied EMF 90 degree only, na? So peak value of the current in the capacitor is what do you say? 90 degree. Understood? This is the origin. Now, these three current vectors at a time I will draw, so that for me very easy. So current phasor diagram only I will consider. Current phasor diagram. Tell me what is the current phasor diagram? This is the IR or I0R. I mean peak value of the current flowing in the resistance. And what is this? Peak value of the current flowing in the capacitor. What is this? peak value of the current flowing in the inductor. Now you people tell me which dominant circuit.
Capacitor.
So very good. Roughly we are talking capacitor dominant circuit. Capacitor dominant circuit. What a resultant of this and this? Net current of capacitor and inductance. Big minus small only, na? From big vector you have to subtract small vector. So the net current is big current direction, net current direction same only, no? So I can write I0C minus I0L. This is what I0R. With these two vectors, construct one parallelogram law. And what a diagonal is representing? Resultant current I0. This is I0, I0. Peak current only I am addressing. So this is an peak current. I mean, net current means net current coming out of the battery. Yes or no? Now tell me what is the net current here. Tell me. Kindly tell me what net current in the this one. IO equal to how much? Under root of opposite side whole square plus adjacent side whole square. So IOC minus IOL whole square plus IOR whole square. This is a net current. Huh? What plus? So because of the capacitor dominant circuit, where capacitor dominance is there, current always leading to the applied EMF only, no?
Yes, sir.
So that's what current is a leader. So what is the phase difference between the net current and net EMF? 45. Huh? How did you say?
Not 45.
Copying, everyone?
Sir.
Copy quickly. Put right 24 cool mode, medium fan mode. That's all. Focus on the lesson.
Then divide by potential difference. We can multiply by you won't get anything.
Okay.
Power.
Shall I slide? Finished, huh? Okay, ma. So now, tell me, everyone, tell me what is the net current? Tell me what is net current coming out of the cell? Under root of IOC minus IOL whole square plus IOR whole square. Peak current is nothing but according to Ohm's law, the three components are acting like a single impedance Z and connected to what? One AC source. How much? E is equal to how much? E naught into sine omega t. I naught value how much? Respond. What I naught value? E naught divided by total impedance. Na?
Yes,
I removed that three components: inductor, resistance, capacitance. I removed. It is acting like a new device of total resistance or total impedance. How much? Z. And under root of IOC value how much? Applied peak applied EMF divided by XC minus peak applied EMF divided by XL, resistance of the inductance or reactance of inductor whole square plus what is the peak current and resistance? E naught by R whole square. E naught square, E naught square, E naught square. How much cancels out? So 1 by Z equal to is called reciprocal of the impedance. Z is nothing but what here? Impedance. Impedance means vector sum of entire opposition given by the three components. Or total resistance, if you call also, nothing will happen. Impedance. The reciprocal of the impedance is called admittance. Which tense? Admittance. That equal to how much? Admittance is denoted by under root of 1 by XC minus 1 by XL whole square plus 1 by R whole square. So tell me when this admittance is minimum? When impedance is maximum. When impedance is maximum, current is minimum. When impedance is maximum, peak current is minimum, but admittance is minimum. To make the minimum admittance, one and only one method, this component must and should be equal to 0 only, na? Yes or no? So that concept is called resonance in parallel circuit. It is a hypothetical only, completely resonance in a parallel circuit. So the at one particular angular frequency where admittance equal to 0, sorry, admittance is what here? Minimum, not 0. Admittance must and should be minimum. Such phenomena is called what here? Resonance in parallel circuit. To accomplish this parallel resonance, what are the things to be done? 1 by XC minus 1 by XL must and should be how much? Compulsory 0. Means 1 by XC is equal to how much? 1 by XL. Means here also we obtain the same condition. When reactance of capacitor or resistance of the focus, resistance of the inductor both are same, then only what will happen? These things, I mean resonance taking place. XC formula how much?
1 by C omega.
Resistance of the capacitance 1 by omega into C. But resistance of the inductor omega into L. Omega into omega how much? Omega square by 1 by L into C. So omega equal to how much? 1 by under root of L into C. So this is called resonating angular frequency. Resonating angular frequency. Okay, so same condition. Na? So just to write an important note, in series combination, parallel combination, same resonating angular frequency is there. Okay, and how questions will come, I will be explaining. This is one inductor. This is one resistor, capital R. This is one capacitor C. This is one applied battery. Here I put one ammeter. Here I put one ammeter 1, ammeter 2.
Sir, can you select the other?
Here one first ammeter A1 I will keep. Second ammeter A2 I will keep. Third ammeter A3 I will keep. Fourth ammeter A4 I will keep. Find all ammeter readings, everyone. Find all ammeter readings. 1 minute time. Try.
Sir, small doubt, sir.
Ask.
In a capacitive circuit and a capacitive circuit, the reactant is 1 by Xc only, no, sir.
Capacitance.
1 by
Reactance. 1 by omega C.
1 by
Omega C. Xc equal to 1 by omega C. Inductive reactance is omega n 12.
Sir, A1 has
Hmm.
E not by X.
E not by
Yes, sir. Yes, sir.
wrong.
Wrong.
Okay, listen. RMS current only, na? All ammeters will measure RMS current. First, I will find how much current flowing in the inductor. How much current is flowing in the inductor? Peak current in the inductor and into sine omega t. Leader or lagger? Lagger. So minus pi by 2 only, na? This step understood, everyone? Our reference is applied EMF only. So that current is lagger only, na? That's what I kept 90 degree. This is a peak current. What is the peak current formula? Peak EMF by XL means E naught by XL value how much? Omega L. But ammeter reading means what? RMS only, na?
So,
Divide by root 2. So I0L by root 2 means E naught by root 2 into omega into L is our answer. Okay, so applied EMF. Fine.
Sir, for the
A2 fine.
A3 we can I say, sir.
Tell.
E naught omega C by root 2, sir. Sir, A3
Correct. Very good.
Sir, A2 equal to E naught by R, E naught by root 2 R. E naught by root 2 R.
Shabash.
A1 equal to I naught sin omega.
Shabash. Perfect. Okay, logically, if it is exam hall, how I will do? Tell me. That is the RMS value in the resistor only, na? What is the formula? Peak current in resistance by root 2 only, na? What is peak current in resistance? Peak EMF by resistance by root 2. That's it. Understood? What about A3? What is A3? Peak current in capacitor by root 2. So what is the peak current in capacitor? Peak EMF by in capacitor by root 2 and XC. peak EMF by root 2 into XC value how much? 1 by omega into C. So omega C will go upside.
E naught omega C by root 2.
I hope everyone understood. Clear? Huh? That's it. You can leave weekday.
That means the questions will come from this.
Question setter is my friend. Huh? Will come or may not come.
Last CVD question came regarding that. So this CVD can cover.
But very important. Advance very important. Mains will not come. Advance good questions will come. Okay. Finished? Huh? Copy quickly. Finished? Huh? Okay, ma. So our next chapter. So alternating currents are completely completed. Now we are entering into very big chapter in your 12th standard. Okay, what is that? Ray optics. What is that, friends? Ray optics. So kindly listen carefully. Optics means what? Study of light. Study of light by using which concept? Ray concept. What is the meaning of ray? Someone tell me.
Beam.
Ray means path of the light. If you switch on any source of light, that light particle will travel in the straight line only, na? Okay, so that trajectory or path of the light is called ray. How will you define ray? Path of light is called ray. The ray is represented by one arrow like this. Left side, source of light is there. Right side, screen is there or image is there. Understood? Source also called as source of light is also called as object also. Okay. Now, before entering into the real study of the ray optics, so at least some basic terms we should know. Right or not? Let me introduce the terms first. Types of light rays. Types of light rays. What is the first one is? Parallel beam of light. So parallel beam of light is nothing but the light rays produced by any far object. The rays produced by which object? Produced by any far object. Any far object is called what here? Parallel beam of light. What is the meaning of the farer? Infinity. Farer means what? Object distance equal to how much? Infinity. For us, what is the farer object? You all people are near. Which are which are below 7 meter. I am the person. Any object that is residing less than 7 meters from me, that is called near object. exactly 7 meter or more than 7 meter, that is called far object
In optics, sir.
in optics. Okay, we'll write down that point also. What is the meaning of the far object?
Exceeding 7.
So the distance which is equal or more than 7 meter is called what here? Far object. What is the meaning of the nearest object?
Less than.
The object which is less than 7 meter is called what here? Nearest object. So 7 meter, almost all you can write infinity. We are dealing lenses, small objects. With respect to object, 7 meter is very larger only. Na? Lens size almost all 2 centimeter, 3 centimeter. Where is 2 centimeter? Where is 700 centimeter? Kindly say yes or no. Okay. What is your lens size?
2 centimeters.
You will wear specs almost all roughly 2 centimeter. Specs I am telling. Understood? Roughly I am telling, right? Don't accurate. Understood? Okay. Roughly to convince you, I am telling. With respect to that small size lens, every object more than 7 meter is called what here? It is very far only. So every far object, if you take some farer tree or farer building, it always produce parallel beam of light. Parallel beam of light. What is the concept of parallel beam of light? These light rays, they will meet or they do not meet? They will meet. But at 7 meters they will meet. At tree only they will meet, no? Say yes or no? So they will meet at infinite distance. So what is object distance equal to here? Infinity. And the second kind of light rays are converging beam. Converging beam of light. In the name itself, it is there. What is the meaning of the converging beam? The light rays about which they are about to meet. The light rays which about to meet at a particular point is called what here? Converging beam. Understood? So these are the light rays. They are meeting at one particular point. Is called what here? Converging beam of light. Next one, diverging beam of light. Diverging beam of light. What a diverging beam of light? Tell me. The light rays which they never meet in the future is called diverging. Na? There is no chance of meeting point no, in the future. So I can write the light rays which they never meet. Which they never meet. Which they never meet is called what here? Diverging beam of light. Okay, so the rays which they meet. The rays which they meet near. Which they meet near is called what here? Converging beam of light. Okay, so now we will enter into the real properties of the light. First of all, reflection of light. Reflection of light. Tell me, what is the reflection of light? Bouncing nature of the light. When light falls on a smooth surface, only smooth surface. Understood? So I will write down that point. Bouncing nature of a light. Bouncing nature of a light when it falls on. When it falls on only which surfaces? Smooth surfaces. Is called what here? Reflection of light. What is the reflection of light here? According to Newton, every light you have to treat like a elastic ball. Elastic ball means what? Like a elastic particle, like a rubber ball. Rubber ball means this is any floor. If you throw any ball with a speed, with what angle you projected, with the same angle it will bounce back, na? With the same speed it will bounce back, na? Okay. If you project a stone, will it happen like this? No, it will never happen. Only it will happen with the rubber ball or elastic ball. So Newton compared light with a group of elastic particles. So that particle name is called corpuscle. Corpuscle. Different colors will have different sizes. If you take yellow color light, it is very smaller in size. If you take red color light, the size of the particle, elastic particle, is very big. So different colors will have different sizes. Okay. What is the actual reflection? This is any plane mirror or smooth surface that is denoted with the symbol capital M. This is one point object. P means what here? Point object. Anyway, slightly I will explain what is this point object. Right now, you are watching me. When I am looking like a point, when I am looking like a point, far distance only, na? So, but here point object meaning it will produce only diverging beam only. Point object always produces diverging beam. Diverging beam of light. So I am taking one P. P means what? Point object. One ray of light is falling on the mirror like this. One ray of light is falling on the mirror. What is the name of this ray? Tell me what is the name of this ray? Tell me. Incident ray. What is the name of this point? Point of incidence. Okay, I will draw one normal line. Students, how x-axis is important in mathematical analysis? In optical analysis, normal line means perpendicular line to the mirror is that much important. Every angle, every distance you are measuring with respect to normal line only. But the angle between incident ray and normal line is called angle of incidence I. As I told you, light is a group of elastic balls. So with what speed it is hitting? With the same speed, it bounces back. What is the name of this ray? Reflected ray or scattered ray. Both are same only. Reflection, scattering means bouncing back. Three are same terms. And what is the angle between normal line and reflected ray? Angle of reflection smaller. Understood? So there are majorly two laws of reflections are there. Two laws of reflection. Two laws of reflection. First one is very important. The incident ray, normal line, reflected ray always resides in the same plane. Here currently in my drawing, all these three things residing on the computer screen. No, so I will write down that point. Incident ray, normal line, and reflected ray resides in same plane. Resides in same plane. And the second one, as I told you, because of the concept of elasticity, angle of incidence equal to how much? Angle of reflection. These are called what here? Loss of reflection. Students, if there is no mirror, if there is no smooth surface, if there is no obstacle, how the ray of light would go? It would go straightly like this only, na? Kindly say yes or no. Because of this mirror, it deviated anti-clockwise like this. Okay. So the angle between original path of light and reflected light is called angle of deviation. So what is the delta is called here? Angle of deviation. Angle of deviation. Delta. How will you write angle of deviation? Tell me. Shall I write from this 180 degree? Shall I subtract I and R? 180 degree, what I will do? I will subtract I plus R. Understood this step? This is a very, very important formula for what? Angle of deviation. And also we know I is equal to small r only, na?
2y.
Yes or no? So put the I value R. So what I can write? Angle of deviation equal to 180 minus I plus I, how much? 2 into I. So angle of deviation how much? 180 minus 2I or 180 minus 2 into R only, na? Both are same. Okay, copy quickly.
Sir, why is I and R can't be 90?
Can be 90.
Then 0 sir.
No, 0, no deviation. It will go, it will come and go like this. This is a plane mirror, na? If the light ray comes like this, mean it will go like this only. No deviation. Finished, Amma? Okay. So now, very, very important concept. Image due to image formed due to plane mirror. Image formed due to plane mirror. See, for example, this is one plane mirror. This one plane mirror, its name is M. Okay. Here one point object. Means one, for better understanding, very small size object I am taking. Okay. And here every distance we will measure from plane mirror only. I mean, you have to fix the frame of reference. I mean, origin here. Okay. Here only. This is a which axis? X axis. What is the name of this axis? Y axis. Z axis coming out of the screen. For you, coming out of the paper. So, this is a pole or origin. The midpoint of the plane mirror where all the distance are measured is called what here? Pole. What is the concept of pole? Every distance is measured from this pole only. Understood or not understood? So, right now, one ray of light is falling like this. What is the type of incidence here? Normal incidence only, na? What is the meaning of normal? Perpendicular. Normal incidence means perpendicular to plane or mirror. Here, this is the point of incidence. What a normal line? This is only normal line, no? For normal incidence, what is the angle of incidence? Very good, 0 degree. Then angle of reflection also how much? 0 degree. Says or no? Means in which path it is incidented on the mirror. In the same path, it will bounce back. Says or no? Okay. So, and one more ray of light, any ray of light is falling like this. What is the name of this point? Point of incidence. What is the name of this line? Normal line. If this angle of incidence I means how it will bounce back? With the same angle it will bounce back, na? So this is another reflected ray. Have you noticed the two reflected light rays? Do they meet really? This reflected light ray number 1, reflected ray number 2. Do they meet really? They do not meet really. But they will meet virtually. Yes or no? If you extend these two light rays like this, they will meet non-really. The point where the reflected light rays are meeting apparently or not truly one surface only. Yeah, it won't meet. Apparently, if gap is there, means they are about to meet. Truly, they are not meeting. Truly, the light ray not breaking the mirror and not meeting. Apparently, lie only. Correct or not? So, virtual. Virtual means what? Non-real. Virtual means non-real, not really. Correct or not? So, where the light rays are meeting, reflected light rays are meeting apparently, or it is a lie only. What the name of that image is called? I prime. Can you catch this image? If you keep your hand in the back side of the mirror, can you catch your face? So it is lie only, na? It seems that your face is behind the mirror, but actually face is not there, nothing is there. It is your feeling, that's all. Understood? So how we can define virtual image? The light rays, virtual image meaning virtual image. How will you define virtual image? Tell me. The point where reflected light rays, meets not really or apparently or virtually. is called what? Kindly respond. What is called? Virtual image. Understood? So if the object distance between object and mirror is small u, but the distance between mirror and the image is also how much? Same. So u is equal to how much here? Small u. Correct or not? I mean, why both are same? See this angle, I mean this angle also I, this angle also I. So this left triangle, right angle, both are same only, na? Isosceles or congruent triangles, na? Means I can write one statement, object distance equal to how much? Very important point, object distance equal to how much? Image distance also. And also height of the object also equal to how much? Height of the image. Why? What is the proof? Object is on x-axis, image is also on x-axis, no? It did not go below, no? Meaning height of the object, I can write one more point. Height of the object is equal to height of object is equal to what is that? Height of image. No. Yes or no? Now, what is the characters of this? I mean, properties of the image? This image is real or virtual? Your photograph is there. That is actually real image. Real image, you can catch, you can touch, you can capture on any screen. Are you understanding? Right now, what is the type of this image? Projector is having lens. All the refracted light rays are meeting on the screen. So this image, what you are seeing is what image? Real image. You can touch it, no? See, I touched it. So the real image means the image which you can capture or you can touch on the screen is called what here? Real image. In theater, now this one, your photograph, these are some examples for what here? Real image. Understood or not understood? Say yes or no. So now, for example, properties of the image. Some properties, if you see, what is the nature of the image? Kindly respond. It is the virtual. Can you touch that? If you are standing in front of the plane mirror, can you catch your image? I prime. I prime. Virtual image only should be represented with the prime only. In physics language, prime means what? Not true. Real. In the max also, imaginary numbers are denoted with the prime numbers. Impossible, no? Say yes or no? I square equal to -1. Correct or not? So like that. So, and all virtual images are erected only, na? Erected means if you are standing like this, in the mirror, image also standing like this, no? Correct or not? So all virtual images are which images? Erected images only. Erected means what? Upside down, not inverted. And third point, no magnification, na? Same in size only, na? If your height is 5 foot, height of the image also 5 foot. I mean, no magnification. No magnification. And what about the fourth one? Respond. What is the fourth one? Tell me. Lateral inversion. Lateral inversion means what? From I am standing in front of the mirror. Listen carefully. Don't write. This point alone listen. I am standing in front of the plane mirror. From my left hand, light rays will fall on the mirror and reach right hand side. From my right hand side, light rays will go and meet on the left side. Means my left become right in the mirror. That is called lateral inversion. Have you seen ambulance surface letters? I think you might be wondered. So that much ambulance they are running, but they typed wrongly. They printed ambulance spelling wrongly. But what is it? There is a purpose, scientific purpose. Why? It's a emergency, most emergency vehicle, no? Understood. 5 minutes late goes mean the patient will die. So the front vehicle who are in AC, they cannot listen horn or anything. So they will see the rear view vehicle with the rear view mirror only. Understood. The front vehicle driver will see that ambulance when he, in the rear view mirror, it will appear correct letters, correct fonts. Understood. So if you see this L letter in the mirror, how it looks like? Lateral inversion. So these are the properties of the, what do you say, image formed due to plane mirror. Is my point clear? Let me introduce a few more things. See, for example, this is a plane mirror. What is this? Plane mirror, and its position is M1. Here one object is there. Object is in the state of rest, students. What a velocity of the object? Respond, what a velocity of the object is? 0, not moving. But mirror is moving. Mirror displays it from M1 to which position? M2 position. Let's say it's a displacement how many meter? How many meter? Tell me. Some x meter it displaced. Yes or no? What is the initial object distance? Tell me what is the initial object distance equal to? Respond. U meters. Where the initial image will form? Initial image distance also at U meter, na? Because just now we found object distance equal to image distance. But you shifted the mirror left side, na? What a new object distance, tell me? Everyone have to talk. How much? From U, you have to subtract x, na? So U minus x. Where the new image will form? Also, from the new position of the mirror, where it will form? Also U minus x only, na? Because object distance is equal to how much? Image distance also U minus x. Then what is the shift in image? This is only called displacement of image, na? Please say yes or no. What is displacement of image? Tell me. Tell me. From this U plus U, how much? 2U. I have to subtract this one and this one, na? Yes or no? I will write that point. Shift in image, or you can also call it as displacement of image. Displacement of image. What I can write here? Tell me. U plus U, how much? 2U minus, bracket will start how much? U minus x plus U minus x, how much? 2U. U minus x plus U minus x. How much that is? Displacement of image equal to 2U minus U plus U, 2U minus 2x. 2x. So 2U minus 2U plus 2x. 2U cancels out. What a displacement of the image equal to 2 into x. So here with this analysis, I want to add one very important note. Means compulsory you have to remember at your fingertips. Tell me what a displacement of mirror here? X. Minus x. Why minus x? Negative side or left side it is going, na? Then What is displacement of object? 0. Object is not moving, no? Then what is the displacement of image?
2x.
Minus 2x. Correct or not? You have to remember. This is equation number 1 and equation number 2. If you divide, what you can write? Displacement of mirror by
It is in the right side of the mirror.
which one?
Displacement. Displacement of minus 2x.
No, listen. In mirror moved in which direction?
Right to negative x.
Left side it traveled. Image also displaced which side? Left side only, na? So same thing I said. If you divide the understood ma, stop me if you struck. For understanding. So displacement of mirror by displacement of image, how much? Minus x by minus 2x. X minus cancels out. So you can write displacement of image equal to how much? 2 into displacement of mirror. Kindly you should remember at your fingertips.
What is the basis?
Yes, sir. Where is this? SI means displacement of image equal to how many times? 2 times of displacement of mirror.
Sir, from this equation you can directly consider that equation.
Yeah, you can.
Exists the displacement of image.
Yes, you can consider. Now, if you divide on both sides with time, displacement of image by time equal to 2 into displacement of mirror by time. But displacement of image by time is nothing but, tell me, velocity of image equal to how much? 2 into velocity of mirror. Yes or no?
Yes.
Okay. So this is a velocity of image equal to how much? 2 into velocity of the mirror. If you differentiate it once again, what I can write? Acceleration of image equal to 2 into acceleration of how much? Mirror. Yes or no? These are called as constant relations. Everyone have to remember velocity of image equal to how much? 2 times of velocity of mirror. Acceleration of image how much? 2 times of acceleration of mirror. Copy quickly. Understood? Now one small problem I will ask. Answer. Listen question carefully, Vishwana. See, this is an object. This is a mirror. Mirror is moving right side with the speed 2 meters per second. And image is there. My first question, find velocity of image. Find velocity of image. My second question, find direction of image.
Sir, what is that? Two, sir.
Mirror is going right side with the 2 meter per second speed. I am asking, object is in the state of rest. Velocity of the object is 0. Find velocity of the image. 1 minute time.
Velocity 4, sir.
Velocity is 4.
Right, sir. Positive. Hostile, sir. Four and positive, sir.
Very good. Why? Velocity of image equal to how much? 2 times of velocity of mirror. Means 2 into 2 how much?
4.
So 4 meters per second is our answer. What the direction of the image? Right side or positive x-axis. I hope you understood very nicely. Now we'll see reciprocal case. What is the reciprocal case here? Now mirror is rest. Now which thing is rest? Mirror is rest. And which thing is in motion? Very good. Object is in motion. Shall I slide up from here to here? Is it okay? Now mirror is rest, object is in motion. Okay. Now tell me. So one example is a mirror. Mirror M is the object O. What is the object distance? U meters. Where image will form? Tell me. Image is I prime. What is the image distance? Also how many meter? U meter. U meters. Yes or no? And now I said mirror is in the state of rest. Means velocity of mirror how much? 0. Object displaced from O to O prime or O1 to O2. Right side displaced. How much displacement? Tell me. X meter. Huh? Left side or right side? Your choice. Now what is the new object distance? Kindly tell me. Very good. U minus X. What is the new image distance? Initial image is here. Where is the new image? I2 prime here only, na? Yes or no? That is how much? U minus X. So what is the shift in this image or displacement of the image? Left side, no? How will you find? Tell me. Displacement of image, how much? Displacement of image. Tell me, students, what is the displacement of image? Tell me. U plus U is equal to how much? From 2U or from U I have to subtract U minus X only, na? Understood or not understood? So I can write displacement of image is equal to from U I will subtract U minus X. So delta I value how much? U minus U plus X. Plus U minus U cancels. So what displacement of image equal to? X meter. Understood or not understood? So I will write one statement. important note also. With your permission, shall I write displacement of image equal to minus of displacement of object? If displacement of mirror is 0, kindly respond. What do you say? Object is moving left side, image moved left, right. Object moved right side, but image moved left side, na? And with the same displacement only, na? Object has shifted x meter, image also x meter shifted, no? But opposite direction. That's what I wrote this relation. Understood or not understood? Okay, kindly remember at your fingertips. On either side, I will divide with time. So what will happen? Tell me. Displacement of image by time equal to minus displacement of object by time. That is how much? Velocity of image equal to minus velocity of the object. Understood? I mean, acceleration of image also equal to how much? Minus acceleration of the object. One small practice problem, kindly address, is a mirror. If object is moving right side with 2 meter per second, what is the image velocity? Find image velocity. Very good, -2. Why -2? Opposite and equal. Understood? Now mixed case. Mixed case. Listen carefully. Stop writing. You cannot focus. Somewhat complicated. This is a mirror. Mirror is going left side with 1 meter per second. Object is going right side with 2 meter per second. Find the velocity of image. Find velocity of image. Complicated, no? Both are in displacements, both are in motion. See carefully and understand how I will take, how I will tackle. You also tackle same way. Now, because of only mirror velocity, what is the velocity of the image? 2, no? Twice. Mirror is moving with 1 meter per second means image will go with double, twice, in the same direction. Say yes or no? Accepted or not accepted? Yes. Okay. Now, because of object motion, image will go 2 meter per second. Say yes or no? Object is moving right side, so image will go left side, same speed. 2 plus 2, how much? 4, that's it. The velocity of image? Same direction, Vishwanath. -4 only. -2, how much? -4. Understood? 2 plus 2, 4. And the image is moving which direction? Left side only. Understood or not understood, everyone? Okay. Shall I give one problem? Huh? Will you do it? Huh? This is your JEE mains question. Every year will ask you, so you try to answer. This is a mirror going left side with 2 meters per second, and object is going also left side with 5 meters per second. Find, first question, find velocity of image. Find what here? Velocity of image and direction also. These are JEE problems, student.
1 meter per second.
One, okay. Kamlesh, one. Left or right?
Right side.
Right side. Okay, next. Cross check. Seven, huh? Kirtika, tell me your answer. 7. Kirtika and Vishwanath and Venkatesh. Direction? Left. Okay. Let me check it out. Okay. It is my turn. Because of only mirror motion, what is velocity of image? Same side and 4. Now, because of only object velocity, opposite side and 5. Both are in opposite direction. Na? So, how much? 4 minus 5. Minus 1 only. Na? 5 is bigger, no? Correct or not? 5 is bigger means resultant velocity how much? 5 minus 4, 1 only. So, net velocity how much? Big velocity minus small velocity, 1 meter per second. And it is also right side. So, Kamalesh is perfect. Once give him a small ground of applause. Well done. As of now, I will, it's a very simple only I explain. Now, in advance, how questions will come, I will explain. As of now, students, listen, focus. I will give time to copy. Kindly focus. As of now, we discussed object is moving on the x-axis, mirror also on x-axis, image also on x-axis. Is there any rule? Object only should move x-axis, y-axis is there, z-axis is there, or in middle also it can travel. That is its choice. Mirror is placed now. One housefly will fly like this. Right or not? Let us see motion along y-axis also. This is a plane mirror. Vishwanath, focus. Okay. If object is here, now it is going upside. I mean along y-axis. Image also will go along y-axis. Na? So here shall I write one statement? If object is going along y-axis, I can write one statement. Displacement of image equal to how much? Displacement of object along y-axis. I mean, there is no change. I mean, velocity of image along y-axis equal to velocity of object along y-axis. Similarly, another case, now object I will keep in the state of rest. Now mirror will go. Mirror is going this side. Is there any change in position of the image? No. Mirror is going or displacing with whatever the speed, image will form at the same location only. Na? You are standing, big mirror is there. Some people are taking away. Your image will not change. Na? Says or no? Means along y-axis, if mirror is moving or object is moving, image is undisturbed only. Na? Kindly say yes or no. Okay, so I will add up that point. If mirror motion is there, so what will happen? Displacement of the object is 0. So displacement of image also how much? 0. Correct or not? Understood or not? It is unaffected. If both are, I will add the both cases. Now you just answer. Is the mirror is going with the speed 2 meters per second. and object is going with a speed 1 meter per second. Find velocity of the image.
1 meter per second.
Shabash. 1 meter per second. Why? Re?
Sir,
Mirror motion do not affect mirror motion along y-axis do not affect the image motion only. Na? Only we can neglect. Are you getting my point? Similarly, z-axis also same thing will happen. Na?
Yes.
Huh?
Yes.
Why?
Middle is.
I'm coming. That's what I am telling to don't copy. I will add these three cases. X, not only Y, Z also I will add. Understanding or not understanding? Okay. So pay your max attention. Now mirror is there. Now velocity of the mirror along Z axis 0. But object is coming in the Z axis like this. Z axis means coming out of my screen. For you out of paper like this. Yes or no? Now if the object displaces from O1 to O2, what will happen? Image also displaces from I1 to I2 along the z-axis. Na? Shall I write one statement? Displacement of the object along z-axis equal to displacement of image along z-axis. Means if you differentiated velocity of the object along z-axis equal to velocity of the image along z-axis. Yes or no? Understood or not understood? Lot of cases are there. Wait, be patient. Now, object is state of rest. Mirror will move. Here, object is in motion. Na? Now, mirror will go. Here, object is there. This is on mirror. Mirror is moving in the z-axis from M1 to M2. Is there any change in image position? No. So, I can write that point. If mirror motion along y-axis, along z-axis, it does not affect. So I can write displacement object is 0 and displacement of image also 0 because of mirror motion. Understood? Now I will mix all these three cases x, y, z. You have to answer. Shall I erase? Shall I lift a slide? Shall I shift the slide? See, velocity of the object equal to 1 into I cap plus 2 into j cap plus 3 into k cap, and velocity of the mirror equal to minus 2 into I cap minus 3j into j cap minus 4k into k cap. Okay. Tell me, find velocity of image. Understood or not understood? Will you try? The J advanced problem. Numbers exactly I did not remember, but the flavor of the question still I remembered. Why? Because I solved it. You try now. With your talent, you have to do it.
Object is moving or
moving only, right? I told now. Velocity of object moving along x-axis, y-axis, z-axis.
But you notice velocity of the object.
O means object only. Okay, anyway, try. You are not in the mood, I know. Question I should solve. First, separately x-axis you take. Mirror is going with what speed? Left side 2, no? Object? Object, tell me. Right side with 1 meter per second. No? Now, what is the image velocity? Left side 4, right side? Left side 1. So, velocity of image along x-axis how much? -5 into I cap. 1 is over, no? Now, along y-axis. What is the velocity of the mirror along y-axis? Sorry, it's going downside. 3 meter per second, it is going downside. And object is going in which direction?
Same that. Mirror it won't change.
2 meter per second. So image also going with the same 2 meter per second. Na? Mirror motion in y-axis, z-axis won't be affected. So what is the velocity of the image along y-axis? 2j cap. Understood? Now z-axis, I can tell directly, but some explanation I am giving. Along z-axis, this is z-axis. What is the velocity of the mirror? Sorry, it is going down. I mean negative z-axis. Going with what speed? 4 meters per second. How the object is going? Positive z-axis. No, it is going like this. So 3. I told here also mirror motion won't be affected. So what the image velocity? In the z direction only and same 3 meter per second. Into the screen is -z. Into the screen I cannot drill. No? It's costly. 65,000. Understood? 1 year also not finished. Okay. Understood? So the z-axis, negative z-axis in 12th net room. Understood? Clear or not? Positive z-axis this side. If you keep one nail like this, na, this positive z-axis. In that room, for this wall, one nail is there, that is negative z-axis. Understood? So I cannot draw, no? So this is the only way. So minus, sorry, plus 3k cap. I will add. What is the velocity of image equal to? Minus 5 into I cap plus 2j cap plus 3k cap. Khatam. What is the magnitude of the speed of the image? Under root of how much? 5 square plus 2 square plus 3 square. So how much? 25 plus 4 plus 9. So 39 is your answer. Root 39. Understood? Huh? Complex things you have to break into simple things. From where? From? Mixed case onwards. Huh? Thank you, students. Try that question in your house.